All right, let's talk about one of the biggest changes happening in the world of networking. We're going to dive deep into the massive shift away from all that tedious, manual work and into the world of smart, fast automation. Seriously, we're going from typing commands line by line to writing code, and trust me, it is changing absolutely everything.
So, to really get this, I want you to imagine something. Let's say you're the network admin at a pretty decent sized company. You're managing, I don't know, 120 switches, a bunch of routers, some firewalls, and your boss comes over and says, "Hey, we need a brand new VLAN, and we need it on all 120 of those switches." So, what's that feeling in your gut right now? Yeah, that's probably dread, right?
So, here's how we're going to break this down. First, we're going to stick with that feeling of dread and talk about the old manual way of doing things. Then we'll get to the good stuff, the new era of automation. We'll look at the brains behind it all, figure out how these machines actually talk to each other, see some Python code do the heavy lifting, and then, most importantly, talk about what this means for you and your future.
Okay, let's start with the problem. This is the reality that so many of us in networking have been living with for years. It's a world just filled with these repetitive, soul crushing tasks that, honestly, cost us way more than just our time. So, back to that VLAN request. The old way? Well, you'd crack your knuckles, SSH into the first switch, type in your commands, save, exit. And then you do it again on switch number 2 and number 3. And you keep going 119 more times. It is literally the definition of mind-numbing manual work. And here's why that is so bad. It's not just that it takes forever. It's that it's a ticking time bomb for human error. I mean, think about it. By the time you get to switch number 50 or 75, are you 100% sure you typed every single command perfectly? Probably not. And that leads to inconsistent configs, which makes finding a problem later on an absolute nightmare. And this right here is the perfect horror story. You're on switch 87, it's late, you're getting tired, and you type switch port mode access when you absolutely meant to type trunk. Just one little typo, and boom, you've just taken down a critical part of the production network. The stakes for one tiny mistake are just unbelievably high. Okay. Enough of the doom and gloom. Let's talk about the solution. Because we are in a brand new era now, and it is all about working smarter, not harder. And we do that with automation. So what even is network automation when you boil it down? It's really simple. It's just using software, using scripts to do all that heavy lifting for you. So instead of you logging into 120 switches by hand, you write one script, hit a button, and it does it for you, automatically. And this isn't just about adding VLANs, right? Think about all the repetitive stuff you do. Backing up configs every single night, pushing out a new security policy to all your firewalls, changing a bunch of IP addresses. All of these are just screaming to be automated. Now, remember that job that was going to take you hours, maybe your whole day? With a simple script, you can get that exact same thing done on all 120 switches in about 15 seconds. Just let that sink in for a moment. Hours of boring, risky work just vaporized into 15 seconds of perfect execution. Now that is power. So you're probably thinking, okay, how on earth is that even possible? Well, the magic behind this is a huge shift in how we think about network architecture. We have to understand the brains of the operation, and that brings us to something called software-defined networking, or SDN. This is the big idea, right here. In an old-school network, every single router and switch has its own little brain, its own control plane, making all its decisions by itself. With SDN, we perform a kind of brain surgery. We pull that intelligence out of every individual box and centralize it into one super smart piece of software we call a controller. And what that does is create this really clean, layered architecture. Down at the bottom, you still have your physical gear, your switches and routers, but now in the middle, you have that centralized brain, the controller. And that means up at the top, your applications can now talk to that one brain to program the entire network. And the benefits you get from this are just massive. You get to manage your whole network from one single place. You can roll out new services like crazy fast because you're just telling the brain what to do, not touching 100 different devices. The whole thing is programmable and perfectly built for the way modern cloud-based stuff works. Okay, so we've got a central brain. That's cool. But how do our scripts actually talk to that brain? How do they give it orders? Well,
They use the universal language of all modern software, the API.
So what is an API? The easiest way to think about it is like a menu at a restaurant. It gives you a list of things you can order and tells you exactly how to ask for them. It's just a set of rules that lets our Python script talk to the network controller and lets the controller talk to the switches. It's the official translator between what we want to happen and what the device actually does. Now, the most common type you'll see is a REST API, and it uses really simple verbs. You use get to read or get information. You use post to create something new, like a new user or a new VLAN. You use put to update something that's already there, and delete to, well, you get the idea. It's just simple, powerful action words for software.
And when these programs are talking, they need to speak the same language, right? That language is almost always JSON. It's just a clean, easy-to-read way to package up data. So when our script uses a GET request to ask about an interface, the controller replies in this perfect JSON format. If the API is the grammar, then JSON is the vocabulary they use.
All right, we have covered a ton of theory: controllers, APIs, JSON. Now for the fun part. Let's see how this all comes together and actually works in the real world. Let's turn all this theory into reality with some Python. So let's take a super common task: backing up your router configs. Imagine a simple Python script. First, it looks at a list of all your router's IP addresses. Then it just goes down the list. It connects to the first router, runs the show running config command, copies all that text, and saves it to a file. Then it disconnects and moves to the next one, and the next. The whole thing, for all 40 of your routers, is done automatically while you go grab a coffee. That's it. So we've seen the problem, we've seen the solution, we've seen the tools. Now let's talk about the big question. What does all of this mean for you, for your career in networking? Well, it means there is a massive opportunity right in front of you. The skills we've been talking about this whole time, this is the new toolkit. Knowing Python, understanding how to use REST APIs and read JSON, having some basic Linux skills, and knowing your way around tools like Git. These aren't just nice-to-haves anymore. These are the core building blocks for the modern network engineer. And why should you care about learning this stuff? Well, because it's incredibly valuable. An engineer who knows networking inside and out and can program, that person is a force multiplier. And as you can see, that combination of skills has a huge positive impact on what you can earn. You become way more valuable because you can get so much more done way faster and with fewer mistakes. So let's just sum it all up. This is the evolution, plain and simple. We are moving from manual CLI typing to Python automation. We're going from managing things device by device to using a central controller. We're leaving behind a world that's slow, tedious, and error-prone for one that is fast, efficient, consistent, and super reliable. Look, this isn't some trend that might happen in the future. It is happening right now. The way we build and manage networks has fundamentally changed. So the only real question left is, are you going to change with it?